Okay, let's take a look at this next problem here. We have a mixture is prepared from 0.9 liters of ammonia and 1.2 liters of CO2. The substance react according to the equation 2 ammonia plus CO2 chlorine gas goes to nitrogen plus 6 moles of hydrogen chloride. If the volumes of all the gases are measured at the same temperature and pressure, list the volumes of all the substances present at the conclusion of the reaction. Okay, now when we look at this problem, the first thing that we need to do, we're told that we have 0.9 liters of this material here, ammonia, and 1.20 liters of chlorine gas. We need to first find out what's the limiting reagent between these two. So the first question that we're going to ask ourselves is how many moles or how many liters of CO2 would be equivalent to 0.9 liters of ammonia. Um, with these types of relationships or this type of equation, we're going to convert our liters of ammonia to moles of ammonia. So in order to do that, we have to say for every 1 mole of ammonia, we would have 22.4 liters of ammonia. Liters of ammonia cancel out. And our answer, if we stop right here, do the calculations, will be in moles of ammonia. But we don't want our answer in moles of ammonia. We want our answer to be in liters of CO2. So we have to use our conversion factor, which says for every 2 moles of ammonia, I have 3 moles of CO2. I put ammonia on the bottom because I want the ammonia to cancel out. I got 3 moles of CO2. Moles of ammonia cancel out. And if I stop at this point in the equation, my answer would be in moles of CO2. But again, I want to have my answer in liters of CO2. So I convert my liters of CO2 into, I convert my moles of CO2 into liters of CO2. And I know that this is done by saying that for every 1 mole of CO2, CO2 is on the bottom, 1 mole to cancel out, I have 22.4 liters of CO2. And in this equation, if that's the case, if I do all my calculations, I will get 1.35 liters of CO2. So this is the amount that's needed. I need this amount. If I have 0.9 liters of ammonia, and I'm told from the equation that I only have 1.20 liters of CO2. So this is what I have, and this is what I need. If I have zero point 0.9 liters of ammonia, then I would need to have 0.135 liters of CO2, but the equation is telling me that I only have 1.2 liters of CO2. So if that's the case, then CO2 has to be the limiting reagent. So CO2 must be limiting reagent. Okay, but before we make that conclusion, let's go back and take a look at our ammonia. How much ammonia production will we get if we have 1.2 liters of CO2? So, how many liters of ammonia is equal to 1.20 liters of CO2? I'm going to convert my liters of CO2 into moles of CO2. For every 22.4 liters of CO2, I'm going to convert my moles of CO2 into moles of ammonia, which comes from my balanced chemical equation. My balanced chemical equation tells me that for every 2 moles of ammonia, I have 3 moles of CO2. For every 2 moles of ammonia, I have 3 moles of CO2. And then I'm going to convert my moles of ammonia into liters of ammonia, which would give me 22.4 liters of ammonia for every 1 mole of ammonia. Ammonia cancel out, CO2 cancel out, liters of CO2 cancel out, and this here would give me 0.8 liters of ammonia. So if I have 1.2 liters of CO2, then I would only need zero point 0.8 liters of ammonia. But from the equation, we're told that we have 0.9 liters of ammonia. So this is what we have, which means we're in excess. This is what we have. This is what we need. So we're in excess. So we definitely know that the CO2 has to be the limiting reagent. If the CO2 is the limiting reagent, we can then base all of our other equations, how much nitrogen and how much hydrogen chloride I would get based on the limiting reagent. So let's do that now. Let's do the calculation. Um, how many liters of NH2, no. How many liters of N2 would be equivalent to 1.20 liters of Cl2. I convert my liters of Cl2 into moles of Cl2. So for every 1 mole of Cl2, I have 22.4 liters of Cl2. And then I also know that from my balanced chemical equation, that for every 3 Cl2, I have 1 N2. So I have 3 Cl2 for every 1 N2. And then I convert my moles of nitrogen into liters of nitrogen. So it's 22.4 liters of nitrogen for every 1 mole of N2. When I do that, what happens is I end up with 0.4 liters of nitrogen. So I have 0.4 liters of nitrogen. So that's how much nitrogen will be produced if CO2 here, which is our limiting reagent. So we would get 0.4 liters of N2. All right, let's see how much hydrogen chloride gas we're going to produce. So let's look at it again. How many liters of HCl is equivalent to 1.20 liters of Cl2? I convert my liters of Cl2 into moles of Cl2. I have 22.4 liters of Cl2. Liters of Cl2 cancel out. I now use my balanced chemical equation to convert my moles of CO2 into moles of hydrogen chloride, which the balanced chemical equation tells me that for every 3 moles of chlorine gas, I have 6 moles of hydrogen chloride gas. And then I convert my hydrogen chloride gas into liters, which would be 22.4 liters of HCl for every 1 mole of HCl, which is equivalent to 2.4 liters of HCl. So, all right, so based on what we've seen so far, we would produce 2.4 liters of hydrogen chloride gas. We would produce 0.4 liters of nitrogen gas, and we would need 0.8 liters of ammonia gas. So the equation says here at the bottom of the equation it asks list the volumes of all the substances present at the conclusion of the reaction. So at the conclusion of the reaction we have 2.4 liters of hydrogen chloride, 0.4 liters of nitrogen gas, and we also would have 0.9 liters of ammonia minus 0.8 liters of ammonia, which would give us 0.1 liters of ammonia at the end of the reaction because it was not consumed. So zero point 0.1 liters of ammonia would be at the end of the chemical reaction, 0.4 liters of nitrogen gas, and 2.4 liters of hydrogen chloride gas.